in this scenario, let's sketch this given triangle, and then they want us to actually solve for B. Now this is uppercase B. Remember in geometry that does mean the angle. This given scenario here, it doesn't have to be drawn to scale. As long as it's labeled properly is all that really matters. I'm going to go ahead in this case and call side B this guy here. Therefore, this here, by the way, has to be its corresponding angle B. I'm going to make this longer one side A, which means this has to be angle A at 68 degrees. If I wanted to, I could label this as angle C and small side C. Now, they do want us to find angle B. This won't work for SOHCAHTOA, nor does it work for law of cosines. So law of sines works nicely. I need angle B. I do have its corresponding side. I do have another pair. I have this angle and that side combo. So I want to solve for angle B, so I'm going to put my angles on the top. So I'm going to write it as the sine of B over 14 is equal to the sine of 68 degrees over 22. Now to get the sine of B by itself, I'm going to go ahead and just multiply by 14 on both sides. I'm going to put the 14 right there. So what I actually have now is going to be the sine of B equals 14 times the sine of 68 over 22. I can put this value into my calculator. When I do that, what I'm going to end up getting is it would look like the sine of B is going to be equal to 0.5900260893. I don't want to round too much because it does cause some rounding errors. Now remember, to get the angle out of the word sine, all I have to do to solve this is do the inverse sine. So the measurement of angle B is sine negative 1 of this same value I'm going to put there. And when I do that, I'm going to get that that angle is approximately 36.2 degrees. Now, I'm going to actually put that in the picture that this is going to be 36.2 degrees and answer the next question. Find the area of this triangle. Now, recall, to find the area of the triangle, I can't use 1/2 base times height because it's not a right triangle. But I can use 1/2 AB sine of C, which means take two side lengths and then take the angle of the other side length and put that in the sine value. I think the easiest one here is to recognize we have these two side lengths, and then why don't I find this angle? This angle is very easy to find because it is just 180 minus the two angles that we have. So this is going to be 75.8 degrees is that particular angle. Setting this formula up, I can do 1/2, I can do the 14 times the 22 times the sine of 45.8 degrees. And once you do that, you're going to get that the area is approximately 149.3. And the units aren't labeled here, so squared units is what we have for that. Keep in mind to compute this area, though, I didn't necessarily have to use these two sides. I could have used this side here and this side AB in this particular angle. If I did that, I would have had to find this angle here, or this side length here for C, which is fine. I would just use law of sines again to find that side length. Another option is I could have used this side length of AC and side length AB with its corresponding angle. And if I did that, using law of sines to find side length C. So lots of different options in finding the total area. They will all give you the same answer.